This is Brunky Tech here. We believe technology is for everybody. We have analog inputs for Arduino today. So what you'll need for this is a power supply. This is optional. An external power supply, you don't need it. But if you want to follow along, it might help. You'll need a breadboard. You need some wires. You need a potentiometer. And you'll also need the Arduino. I have the A4 here, so that way I can cover the full basis of all the code that you can implement on Arduino for your analog inputs. All right, each A to D converter or analog to digital converter has a resolution bit that you need to worry about. All right, so you have an 8-bit analog to digital converter. So that has 256 positions. So in EE, when we talk about 256 bits, what we're really talking about is 0 to 255 because we count 1 as a bit. This is 10-bit or 10 to the power 2 or 1024 different possible values. Now these go up to 12-bit, 14, and 16-bit, and each one of these go up by a factor of the power of 2. So there's more that are larger than what I'm showing here, but we won't discuss those any further. So when we look at the resolution, we can make a determination on what the value of the voltage is based upon our resolution. So on our 8-bit analog to digital converter, we can assume a 19.6 millivolt voltage increase when we have a 5-volt input. Now this gives us an accuracy of 0.39%. So this is a theoretical accuracy. When you actually get into the real world, there's real world voltages and disruptions on your voltage line that's going to increase this, or excuse me, that'll decrease this accuracy as you go along. That's why when you have systems, you don't always need the best resolution on your A to D converter because it's not really something that can be possibly realized when you have noises outside of the system that affects your reading. And so it's not necessarily possible, to get this level of accuracy without some really fine tuning and expensive equipment. So just keep this in mind. So here we have off of the Arduino website, the different Arduino boards and what their maximum resolution is, as well as the pins that you can use for this analog to digital converter. So if we take the example that we have today, we have the Uno R4. So this is a 5 volts that you can put in there, and then you can actually use the pins A0 to A5. So all those pins can handle the read of the analog to digital converter. Now what's interesting about this board is you have a 14-bit resolution. Now you can go down to the Giga R1 that goes all the way up to a 16-bit resolution. So let's jump into the code so I can show you what exactly is going on. All right, for this portion of the project, we're going to use one of these potentiometers. The thing about these guys is you have this wiper in the middle, and you have the top and you have the bottom pin. So when you turn this, there's a proportional voltage, or excuse me, there's the voltage divider that you have here. And when you turn it, it outputs a different voltage. So with this device, we can output a 0 volt all the way up to 5 volt by just turning the knob. So this gives us our full range that we want to take a look at. So this is how we'll set it up. So we'll have this middle pin that will be set going into the A0. We have the top pin. We'll go ahead and set that going into the 5 volt reference that's on your board. And then we have this ground that'll go to the ground on your board. All right, let's go ahead and call out 2 different values here. Let's call out and define a float. Let's call it num. Let's set it to equal to 0.0. Let's go ahead and go float. Let's call this AN. Let's set this to 0.0. All right. Now in this void setup area, we're going to go ahead and call out serial.begin. Call it the baud rate. We'll set this to 9600. All right. That's it for the void setup. So let's go ahead and go into the void loop area. So we're going to set AIN is equal to analog read A0. Let's set it for A0. All right, I went ahead and did a conversion here. So whenever you pre-input an analog value, you might want to convert that to a different value so that way you can utilize that somewhere else in some other code. This is typical practice within the industry. You're not going just to take that A to D value and then use that as is. You want to convert it to some other form. So here we're going to convert it to percent. So we want to convert it so that way it says, and it reads in a 0 all the way to 100%. So we're going to call out the number, and then we're going to do AIN, and then we're going to divide this by that resolution that we had. So your resolution is 1023, and then you're going to times that by 100%. So that will set your value to 100%. That should be somewhere between 0% and 100%. So if AIN is 0, or you can't divide by, if it's 0, you times it by 100, it's 0. But if it's 1, it's going to be low. I'm going to just copy and paste the rest of this in. So on here, I'm having it output and tell me what the analog value is. And then right there, I'm going to pull in the analog value right there. And then under the number, I'm going to put in number. So the first part of the code on the serial print calls out what that value is that we're reading. So it'll be a value between 0 and 123. And then final, this section of the code, it calls out that percentage value. So we put a delay in here. So that way you don't have to look what's going on. We're going to go ahead and build the sketch. I'm going to make sure we have the right board and the right COM port set up. And then let's compile. All right. It's done compiling. So let's pull up the serial monitor. So when I turn this, I have it all the way down. When I go all the way left, when I start turning it, it turns it all the way up. Now the analog input value is changing. So we see it's 156. So that's telling us our throttle percentage is 15%. Now let's go all the way up. All right. So that's that first part. All right. We're going to swap it up, and now we're going to actually change the resolution on our Arduino. So this guy has a resolution of 14 bits. So the default that it's set into the code is actually 10 bits. So let's go ahead and change that. So we can change that by saying it's the analog read resolution. And we will set this to 14. Now, since we changed that, we have to change this value right here because we're dividing by the resolution here. We could do some fancy code to have it do it for us, but I think that's beyond here. and I don't think you'd actually need to do that. So when it's 14-bit, this number is 6383, 13683. So let's go ahead and it's done compiling. Now let's upload it. All right, see that 16383 value showed up? That's what we're expecting, right? So our conversion's right now. So our throttle percent is 100, and as we lower it down, we can see that it goes down as we expected. Right? It doesn't get all the way down to 0%, but it's close enough. You're going to have that issue. That's why when you do this, you're going to have some buffer on your high end and your low end on sensors that bring in an analog signal. All right, for this last one, we're going to pull in a different reference source. So if this potentiometer was using a different voltage reference, you'll want to be able to pull that into your Arduino. So there is a specific pin that calls out V reference. So you'll want to connect V reference to your power reference that you're bringing in. And then you'll want to connect the ground to your power reference to the ground of the Arduino. So we can go ahead and set this up into the code like so. Now, this next part on this call out is going to be determined on which board you have. So I have the Arduino Uno 4. So this is going to be called out as AR_external. Now this go ahead and it tells your analog reference that it needs to be referencing this external voltage. So I need to set that up on the actual board. Let me get it to compile. So on this board, it says VIN. So this is the VIN voltage source that you're putting in. And so there you go. When it turns off and on, just like we expected. So on the input, I used a 3.3 voltage reference, and it gives us the correct values that we're expecting. Why? Because I told the program to reference this VIN pin instead of the internal reference source. Hey, thank you for tuning in. I hope you learned something. If you like this content, hit a like button, subscribe, and if you didn't catch my other video about digital inputs, you can go ahead and check it right here. It'll pop up somewhere on the screen. Have a good day.